Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn how to do a significance test for a mean. All right, so an example of a significance test for a mean. A school librarian purchases a novel for her library. The publisher claims that the book is written at the fifth grade reading level, but the librarian suspects that the reading level is higher than that. The librarian selects a random sample of 40 pages and uses a standard readability test to assess the reading level of each page. The mean reading level of these pages is 5.2 with a standard deviation of 0.8. Do the data give convincing evidence at an alpha of 0.05 significance level that the average reading level of this novel is greater than 5? All right, so our parameter is going to be mu because we are working with averages. So mu is the population mean, is the true mean reading level of all pages in this novel. My null hypothesis would be that mu equals 5, which is the claim, and then the alternative is that mu is greater than 5 because they specifically use the term greater than. And because my alternative is greater than, my null could be less than or equal instead of just equal, but we can only test at one value, so I'm going to keep it with the equal. X bar, my sample mean is 5.2, which is greater than 5, so that's giving us some evidence to support our alternative. And our alpha value is 0.05, which was told to us. All right, plan. The procedure we're doing is a one sample t-test for mu. Your calculator just calls it a t-test. We need to check the conditions. Random. It said that it was a random sample of 40 pages, so that was stated. And then the normal large sample condition, my sample size is 40, which is greater than or equal to 30. So by the central limit theorem, that is large enough. My sample mean, X bar is 5.2. My sample standard deviation is 0.8. I'm pulling that from the information that was given. My degrees of freedom is the sample size minus 1, so 40 minus 1, which equals 39. If I calculate my test statistic using the formula, this formula is on your reference sheet, 5.2 minus 5 over 0.8 divided by the square root of 40, I get 1.581. If I draw this, it's a t-distribution with 39 degrees of freedom. I put 0 here. I'm going to go to my test statistic, which tells me how many standard deviations I am from the mean, and shade above because it's a greater than test. And I'm going to use my calculator, stat, test, t-test. I'm going to use stats. I'm going to enter my information. Mu naught would be 5. X bar would be 5.2. SX would be 0.8. N would be 40. And I'm doing a greater than test. And you should get your test statistic, the t of 1.581, and the p-value of 0.061. And then our conclusion would be, because our p-value is greater than our alpha value, we fail to reject the null hypothesis because our p-value of 0.061 is greater than our alpha value of 0.05. We do not have convincing evidence that the mean reading level of the novel is greater than 5. All right, a two-sided test and confidence interval. A confidence interval gives more information than a significance test does. It provides an entire set of plausible values for the parameter based on sample data. The connection between a two-sided test and a confidence interval is even stronger for means than it was for proportions. So, if a 99% confidence interval for mu does not capture the null value, we reject the null hypothesis in a two-sided test at an alpha of 0.01 significance. So you can see that the 99% confidence level and the 0.01 significance level, those come together to make 100%. If a 99% confidence interval for mu captures the null hypothesis, then we should fail to reject the null hypothesis in a two-sided test at an alpha of 0.01. The same logic applies to other confidence levels, but only for a two-sided test. Okay, so if it was a 95% confidence interval, then my alpha, my significance level, would be 5%, 0.05. All right, confidence intervals for two-sided tests. The CDC recommends that school-age children get 10 hours of sleep per night. A principal at an elementary school wondered if the average sleep time for students at her school was different from 10 hours. She selected a random sample of 45 students and surveyed their parents about how many hours of sleep they typically get on a school night. The sample mean was 9.7 hours with a standard deviation of 0.68 hours. The 99% confidence interval for MU, the mean sleep time of all students at the school, is 9.43 hours to 9.97 hours. Based on the interval, what conclusion would you make for the test with a null hypothesis mu equals 10 versus an alternative mu does not equal 10 and an alpha of 0.01 significance? So we did a 99% confidence interval. So I have that 0.01 alpha that matches. It's a two-sided test. So I'm looking at my interval to see if my null value, 10, falls in the interval, which it does not because my interval is 9.43 to 9.97. So the 99% confidence interval does not contain the null value, mu equals 10, as a plausible value. So we reject the null hypothesis at an alpha of 0.01 significance level. We have convincing evidence that the mean sleep time of all students at the school differs from 10 hours. Okay, we also have evidence that it's less than 10 because our entire interval is below the 10. All right, go Seahawks.